The second type is exclusive locks, which prevent other processes from placing any type of lock. Okay, so the FCNTL system basically it places locks or record locks on any region of a file, ranging from a single byte to the entire file. Two types of locks may be placed inside this FCNTL. Number one is the read lock, and the second one is the write lock. Both of them have similar compatibility semantics to the shared and exclusive locks, which we have discussed earlier, and that can be placed via flock. Okay, so if a blocking lock request would bring about a deadlock situation, then the kernel causes FCNTL to fail with an error in one of the affected processes. Okay, locks placed using flock and FCNTL are invisible to one another. Okay, except on system terms that implementation flock using FCNTL. The locks placed via flock and FCNTL have different semantics with respect to inheritance across fork and release when file descriptors are closed. Okay, so the Linux specific proc/locks file displays the file locks currently held by all the processes on the system. Okay, so let me just write here the path of that file as well, process/locks. Okay, so this file basically it held, so basically this file displays the file locks currently held by all processes on the system. Okay, so now let's do a small example and let's try to understand this concept of file locking. Okay, so we'd go here in the C program.c. First of all, we'd include a few of the libraries. So we'd write here hash include. The first one is, as we always have, stdio.h, and I keep calling them libraries, so pardon me for that. These are not in C you call them header files. Okay, so this is not a mistake. All right, so I have this habit of calling them libraries. You can call them header files, and actually they are header files. Okay, so then you basically include another one, include errno.h, and the fourth one that you include is basically fcntl.h. okay, fcntl.h, and the last one, the last library or the last header file that we have to have is unistd.h, because we are gonna use the exit function as well. So now we come inside the main function, and in here we are going to write our code. Okay, so first of all, the very first thing that we are required to do is that we have to create a structure. Okay, so we create here a struct flock. Okay, and we name the variable, let's say flk, and then equal sign score wrlck comma, and then we write here seek underscore set. Okay, then we put a comma, and then we write here null, null, and null as well, 0. Okay, and after that, what I'm gonna do, that I'm gonna use that flk variable, the structure flk dot l underscore PID, let's say. Okay, and then we put an equal sign here, and then we get the process ID using get PID function, and after that we put a check here. We also need to pass two arguments in the main block, int argc, okay, and comma character steric, and then we write here character steric argv. Okay, so if you are familiar with Java, in Java we used to have two arguments in the main block as well. So here we are passing it because at the time of the running of the function we need it, and we need to check a few of the things. So what we would do, would write here args or argc, excuse me, argc is greater than 1, then we want to put the lock, okay, or the read lock you can say, or file lock. If argc is greater than 1, then we want to put a file lock, or more specifically you can say the read lock. Okay, So for that, what we would do would write here flk, then we'd have here open, and inside this open function we would write here the name of the file, which is essentially cprogram.c, and then we put a comma here, and after that we put o here underscore rdwr. okay, after that you check if that returns -1, then it means that there is an error. So you create a body of the if, and inside the if you basically write here the error, p error, and we write here error in opening file, and you know, it could be that that file doesn't exist, or you know, it could be any kind of error, but in that case it would basically print out this statement. Okay, and now would basically exit, have here /n, so that it goes to the next line. So once you do that, after that you need to catch that enter key, and you need to write here get char. okay, and once you get that, after that you basically have to you know, set a variable to unlock the file as well. Okay, first it would lock it, and then you have to unlock, could lock the file or not. Okay, so after that we put an if condition in which we basically put a small check in which we see if the file can be locked or not. Okay, so we write here fcntl, and then we write here pass basically the arguments. First of all we pass fd, and then we pass this f underscore set lkw. So this f underscore set lkw, this is the argument that tells fcntl function to attempt to obtain the lock requested in the structure flock. Okay, so if the lock cannot be obtained since someone else has it locked already, in that case fcntl function will wait, okay, until the lock has cleared, then will set it itself. This is a very useful command. Okay, so similarly you can see here that we have l underscore type, and this is where you basically signify the type of lock you want to set. You know, it's either read lock or it's write lock. Okay, or you can unlock as well. All right, then you have this lpid, this is the process ID of the process dealing with the lock. Okay, and now you basically put a comma here, and then you use the flk. Okay, you point to it. Okay, then you put a double equal sign -1. all right, and if that is, you know, a -1 is for error. Okay, for some kind of error in the function. So let me just hit enter and make it here the code. So now inside of here what we would write here p error. Okay, and inside this p error basically we would write here fcntl error. Okay, and after that we put a semicolon here, and we basically exit it. Okay, so once you exit it, after that you /n here, you come out of it, and in here you again encourage the user to hit enter to unlock. Okay, so for that you would basically print f here, and you would say hit enter to unlock the file. Okay, so then we put a /n here, put a semicolon, and then in order to detect the enter we write here get char. Okay, and after that we'd basically use the file type. Okay, we write here flk.l underscore type, and we basically write here f underscore unlock. Okay, basically this is the flag that is being used here to set the unlock. Okay, then after that you would use the same fcntl check once again. Okay, but with one different argument. Okay, so here instead of f set lkw we'd write here f underscore set lk. Okay, if we talk about this f underscore set lk, then this function is almost identical to f underscore set lkw. The only difference is that this one will not wait if it cannot obtain a lock. It will return immediately -1 if it cannot obtain. Basically come out of this if check and you write here the print statement and you say basically yes, file has been unlocked. Okay, then you put a /n here as well, semicolon, and finally you basically close what you have started. Okay, close fd. So now basically we are all done. So in here we basically have included our file cprogram.c, which is the own file in which I'm writing the code, and the user basically, when it would hit enter, then my terminal would wait for another enter before unlocking it. After one hand enter, it would be locked, and then it would wait for the input from the user. Then if the user hit enter again, then it would basically unlock the file. Okay, so now let's see if that thing is working or not. So right now you can see we have two terminals. Okay, so if I kind of run my program here, okay, and basically if I run it, you can see that it says hit enter to lock the file. So if I hit enter, you can see that it says checking if we could lock the file or not. So after checking, it says we have locked it successfully. Okay, there was no error, so it has locked it. So now it says hit enter to unlock the file. So we can hit enter and you can see that it says yes, file has been unlocked. Okay, so let me try it another way, that I go to the other terminal and here I do the same thing. I basically run my program and then I run it again and it says hit enter to lock the file, and you can see that basically it says we have locked it successfully. So the file has been locked. So now if we come back here again and if we try to run our program in this other terminal, and if we hit enter, you can see that it says hit enter to lock the file. But if we hit enter, you can see that it says checking if we could lock the file or not, but it is still checking. It cannot lock the file because we have locked the file here, right? So after a few enter hitting, you can see that nothing is happening. It's still checking. Okay, so it would take a while until it basically returns you the error. Okay, so the idea is that it is going to wait because we have used so the idea is that it is not going to stop. It is basically going to wait because of the flag that we have used. Okay, so we have used this one, set lkw, right? So it is going to wait until we basically unlock the file from here. So let's try to unlock the file from here. So you can see that it has basically locked the file and it has unlocked it as well. Okay, so the next topic is sockets. So sockets allow communication between applications on the same host or on different hosts connected via a network. Okay, so the idea is that a typical stream socket server creates its socket using socket method. Okay, so let me just write here. Okay, so I'll write here socket. So this is the method, and then basically bind the socket to a well-known address using bind. Okay, so we will be using these methods. So each client connection is then accepted on the listening socket using the accept method, which returns a file descriptor for a new socket that is connected to the client's socket. Okay, so a typical stream socket client creates a socket using a socket method and then establishes a connection by calling connect. Okay, and basically that connect method specifies the